Slivers can also form, and a lot of these are caused by subsurface oxides. So these are the 8 mechanisms that can cause fines. This is a picture of what the fines that would look like if they were caused by abrasive wear, simple abrasive wear, that is by the diamond die or carbon die touching against the soft aluminum for copper. And that can occur if you've left the dies in service too long, if you get wear rings or grain pullout. This now, it turns out, you can see some of the grain boundaries. This is a polycrystalline die. Now, most fines are caused at the grain boundaries of the polycrystalline dies. Those tend to wear out. So the finer the grain size, the larger the amount of grain boundary area in the die, and therefore the greater amount of fines that will be generated downstream. So consequently, if you are drawing either copper or aluminum and you want to reduce the amount of fines, you better go to a coarse grain polycrystalline die. Now, initially, when polycrystalline dies came out, a lot of people, especially magnet ore companies and others, went to fine grain polycrystalline dies, because they thought it would give a nice, smooth surface. That might be true, but on the other hand, the amount of fines generated is so great, you really shouldn't be using them if you're going to be making copper or aluminum ore. They're okay for some of the steels and other hard materials, but definitely will be a problem if you're making the very soft copper or aluminum. And so you might get a rough, if you ever see wire that has a rough surface like this, this is usually an indication of fines that got put inside the, the drawing die, that got compacted, and that would adversely affect lubrication.